Our topic is to find the maximum height, total time, and the distance traveled in the two-dimensional projectile motion. If we take a closer look that an object is launched with an initial velocity of 37 meters per second with an angle of 44 degrees, and if we are resolving this initial velocity into its components, so we can see that the x component of the initial velocity is the equals to the initial velocity times cos of the angle of theta, and similarly the y component of the initial velocity is viy, which is equals to vii sine of the theta. So when we substitute the values, which is 37 times sine of 44, that will be equals to 25 meters per second, and the initial velocity of the x component will be 26.6 meters per second. The important thing which we need to understand here is in the projectile motion, as the x and y components are both involved in it, the initial velocity of the x component will remain constant throughout the projectile motion, where we can see the initial velocity of the y component is constantly changing. So at the time of launch, the initial velocity we can see is maximum, but gradually we can see at the highest point, at the maximum height, the initial velocity of the y component is 0, but we can observe here that the initial velocity of the x component will remain constant. To find the maximum height, as we are finding the maximum height of the projectile, so we consider only the vertical component of the initial velocity, which is very important to understand. So this height we need to calculate, which is delta y. The important thing to understand here is that the initial velocity of the y component is 25 meters per second. The final velocity of the y component is 0 meters per second. Delta y we need to calculate, and acceleration due to gravity, which we can say g, is negative 9.8 meters per second square. Now we have the kinematic equations which we all are aware of. Vfy equals to viy plus gyt. Delta y equals to viy t plus 1 by 2 gyt square, and vf y square equals to viy square plus 2 gy delta y. If we take a closer look in our data, we have an information of the initial velocity of the y component, the final velocity of the y component, the height we need to calculate, and the acceleration due to gravity, which we have taken negative because the acceleration due to gravity is towards the center of the earth. If we see the first equation A, we cannot use this equation because we don't have an information. We cannot calculate delta y. There's no information. Delta y is not in this equation. So we'll cross this out. The equation B, we have delta y which we need. But the problem here is the information of the initial velocity we have, but there is no final velocity of the y component in this equation. So we will not use the equation B as well. So if we take a look on the equation C, the final velocity of the y component and the initial velocity of the y component, we have the information of these two, and also the acceleration due to gravity, and delta y we need to calculate. So we can isolate delta y, which is equals to Vf y square minus Vi y square divided by 2gy. When we plug the values, delta y as final velocity of the y component is 0, so we'll reject that, and minus 25 square, and then we have a 2 into negative 9.8 meters per second square, and this is meters per second. So after calculation, the maximum height we will have will be 31.8 meters. So this is our maximum height. To calculate the total time of flight, we need to understand one part. If we calculate the total time from the launching position, from the initial position to the point where the initial velocity of the y component is 0, we will calculate the half part of the time of the total flight. So what this means, after calculation, you'll be able to understand in a more better way. So we have information of the initial velocity of the y component, which is equals to 25 meters per second. The final velocity of the y component, which is 0 meters per second. Acceleration due to gravity, which is negative 9.8 meters per second. Again, because we are taking negative for the acceleration due to gravity, because it's directed towards the center of the earth. And delta y, we know it's 31.8 meters, and we need to calculate the time of the flight when the final velocity of the y component is 0. So for this purpose, we will use an equation Vf y equals to Viy plus Gyt. So the final velocity of the y component is 0. Initial velocity of the y component is 25 meters per second. And the acceleration due to gravity is 9.8. So when we'll calculate this, 25 meters per second divided by negative 9.8. So this is the time of the flight, t equals to 2.55 seconds for the half of the distance of the flight, which means that we are calculating from this point to this point. So we have calculated the time of the flight of the projectile when the initial velocity of the y component is 0. So to calculate the total flight, we need to add another half of the time, which is the total. 2.55 plus 2.55, which is equals to 5.1 seconds. So this is the total time of the flight. Total. Now we need to calculate the horizontal distance of the projectile. Horizontal distance of the projectile. So what we need to do? The important thing to understand here is that before we were just taking the initial velocity of the y component. Now the time taken, if we take a closer look here, the time taken in this whole flight for the y component and the x component is same. So we can say the time which we have calculated for the y component, the time of the flight that we have taken the y component in this situation, we can say that the ty equals to tx, which means it is the same for the horizontal component. So 5.1 seconds will also be for the horizontal component of the initial velocity of the projectile. And if we take a look that the initial velocity of the x component is 26.6 meters per second and the total time of the flight is 5.1 seconds, we can use an equation delta x equals to 135.66. So the equation we have used is delta x equals to the initial velocity of the x components times time. So time is same for both x and y components. We have used this equation. This is 26.6 times 5.1 seconds. So this is our horizontal distance.